Hello, my name is Revanth Palreddy, and today we are going to talk about the project Skin Disease Detection using convolution neural networks with dropout techniques. So, this project talks about detecting various skin diseases a person has. So, for detection, we used convolution neural networks with a small introduction of dropout techniques. So, next, the problem statement. We know that the skin problems are the fourth most common cause of human sickness. Many people who are affected do not seek medical assistance. We see in a study 1,662 people out of 2,700 patients at least had one skin abnormality. This is a very concerning problem. So, as people get older, skin illness become more and more common. You see that men has 72% and more of them than women, 58%. Almost two-thirds of the people who are impacted had no idea what was wrong with their skin. So we tried to help these people. So we are trying to design a convolution neural network so as to detect these diseases. So if we had an app in a phone, if you just click a picture and show what type of disease you have, the person might get like in advance that there is a disease, and he'll contact the doctor. So that is our main aim. So traditional segmentation approaches such as thresholding, clustering, edge, and region-based techniques, as well as the widely used ABCDE methodology, continue to struggle with the intricate visual appearance of skins and are unable to detect the skin lesions. Okay, now about the introduction. Using convolution neural networks, I constructed an automatic skin disease detector that can detect and predict numerous skill illnesses in this research. For this, I chose mobile net convolution neural networks to accomplish this goal because they are the most data driven models with the best level of accuracy in all domains where they have been tested. This model is built in such a way that it is computationally effective. The model which which I have used got an accuracy of roughly 85% when evaluated with the Kaggle dataset. Apart from that, I have achieved a 98.5% accuracy to predict approximately 3 diseases out of the 6 diseases I plan to detect. So, the dataset which we got is from Kaggle. This is a 10,000 piece collection from 7 various skin diseases. So, the below are the following diseases which I have found. So in the data classification, there are 7 diseases. Like as you see that we see that navy has the highest number of photographs involved. So the problem about the skin challenges about the skin detection. You see that in the image there are various type of skin diseases. You see most of them are hard to detect. So there are various challenges involved in detection of the skin diseases. The enormous variation of appearance of humans' skin color makes the skin identification a difficult and time-consuming task. So we used this convolution networks to solve it. So the first step involves the data processing and the augmentation. We have seen that there are tens and thousands of images. So each disease has many multiple images, like taken from different angles. So what I did was I narrowed it down, taking the unique images of single person. So for that we aggregated the liaison IDs from the Excel sheet and merged and moved the only ones with one image. From the distinctive list, we conducted a training and validation set. Second, we split the data into 2 lists, training and validation. All the photos are divided into training and validation groups based on labels and a list. We discovered that Navis has 5,954 images out of the 10,000 images, and the training set for the remaining diseases contains a lower number of photos. So we have to do something about it. Only one image is the highest. So what I did was I took all the images, the lesser number of images. I used data augmentation. What I did was I zoomed the image, I rotated the image, I did various manipulation of the same image so that it could be fed to the neural network. So as a result, we decided to increase the number of photos for each subgroup to roughly 6,000. So when you see the image in this, you see the left image consists of all the diseases. You see that the Navius disease has the highest number of photos, whereas the other diseases are very low. So after the data augmentation, I made sure that almost every disease have equal number of photos so that it could be easy for the training. So for the next step, I use the convolution neural network. Convolution neural network is a deep learning method and a type of artificial neural network that is mostly employed in image recognition and processing. A CNN takes an image as an input and assigns priority to various characteristics of an image, following one object in the image to be distinguished from another. So, I have taken the help of mobile net convolution neural network. I specifically took this because we know that convolution layers apply a filter to the image. When the image has more than one color, for example, our photos have RGB colors, this becomes extremely difficult to compute as a color image which has 3 channels. Depth-wise separable convolution is used in this case. This is what distinguishes mobile net and makes it much faster than the other networks. So when you see this, I trained the mobile net using various lines in the code. So there are almost like total parameters of 3.2 million parameters. I just took a few of them. I took 1.8 million trainable parameters and non-trainable are 1.3 million. So for the training part, in the first step, we have defined some useful variables like the number of training images, the number of validation images, the batch size, the validation batch size, and image size, which are useful for the training of the model. Because MobileNet uses transfer learning, the next step is to pre-process the data. So a few of the layers in this networks are retained to work with the skin disease images. You see, as you saw from the previous slide, that the number of trainable parameters are very large. It's in millions. We only need a few of the layers. So I dropped a few layers which can be helped to only work with the skin detection images. So, and the other thing is that the MobileNet accepts only the photos with 224 into 224 dimensions. So we had to pre-process the data and cut down the image to 224 into 224 to meet this requirement. So next, I added a dropout layer in the model. Dropout is a regularization technique that is applied during training of the model, and its main purpose is to lower the complexity of the model to avoid overfitting. To avoid overfitting, the dropout is utilized. This is possible if the network becomes extremely adept at classifying the data you input it. Using the dropout technique, we randomly remove specific neurons in the layer with the probability p from the Bernoulli distribution. Therefore, if half of the activations are set to 0, then in the training, given feed forward pass, the neural network will not be able to depend on specific activation. As a result, it will learn differently, and the neural network cannot depend on specific neurons and their combination. An example for the dropout technique. You see that a standard neural net, for the input part, all the neurons are connected to the next layer of the neurons. Every neuron is connected to the next layer of the neurons. But after applying the dropout techniques, you can see that in each layer, some of the neurons are randomly avoided to avoid overfitting. This is called the dropout technique, which I've been using in the current projects so as to make it much faster. So next, following this, we added a dense layer. The dense layer is nothing but the last layer which we add in the convolution neural network with the softmax activation function with 7 outputs. Since we have 7 diseases, there are 7 outputs in the convolution neural network. This layer gives the final prediction when an input is fed. Next, we freeze all the layers except the last 23 layers and train our image on this layers. This process increases our training speed drastically with little trade-off accuracy. So when we see that, I gave a 10 epochs and saved the model with the best accuracy. Along with the mobile net model, I also created a VGG16 model with the same data and parameters to complete the training accuracy and validation accuracy. The VGG16 is developed by Google. So as the result, after we set up the parameters and fine-tuned both the mobile net and VGG16 models, we compiled and start training the data with 10 epochs. The mobile net achieves an accuracy of roughly 85% when evaluated with the Kaggle dataset. We believe that having a large number of photographs to train the data would give us more accuracy. Apart from that, we got a good accuracies of 95% for the top 2 and top 3 skin disease predictions. Now, when we compared it with the VGG16, we got an accuracy of 675%, but the main thing is that the training took around 6 hours, which was way longer when compared to the mobile net model, which took only approximately 20 minutes to train. This is mainly due to the huge number of parameters in VGG model. As you can see, the training accuracies here. The first is the training and the validation accuracy. As you see, the green line is the training accuracy. The validation accuracy is around 85%. Now, when you see the top two accuracies and the top three accuracies, we see that there is a accuracy of 95% to detect the image. And finally, the last image shows us the training loss and the validation loss. You see that the losses gradually decrease as we increase the number of epochs. Next we drew a confusion matrix to evaluate how good our model was. Since this is a classification problem, a confusion matrix is very necessary to see how good our model is. As you can see in the confusion matrix, we see that the diagonal elements refer to the correct classification. You see that most of the diseases are correctly classified. You see that there are 718 images in Navy which are being correctly classified. A few of them vary, but most of them it's correct. As you see the results from the right side of the table, you see that each disease has its own accuracy. You see that the navies, which was the highest number of images, got the highest accuracy of 0.94. So, conclusion: we developed an application that can forecast skin diseases with 95% accuracy. The next is that the prediction may be low after a few years because our program is limited to only 7 skin conditions and we have only worked with 6,000 photographs for each illness. In terms of accuracy and speed, our model has performed admirably. This is because this is made possible by the components we have used. CNN requires significantly less pre-processing than other classification techniques. Thank you.